Hey, seventh grade. We are going to look at some mathematics today. Lesson 27 talks about laws of exponents. And you've probably heard every law was meant to be broken. I don't think that'll work for you here, but you could try it. You should have this piece of note paper there. So let's get ready to rock and roll here. Basically, this is telling you, sometimes when we deal with exponents, it's not logical. I mean, kind of what we call counterintuitive. It's not what you think. So this is something to pay a special attention to here. And we're going to start off here with this. What happens? And you probably don't write anything over here just yet, because I think it'll help if we put some stuff over there a little bit later. So go below that little box and let's talk about it below that. You can jot some notes down here just to kind of get us thinking a little bit here. For this first one here, right here, you'll see they have letters here instead of numbers. Well, that's because in math, we use variables because you want to be able to put any number in there and let it work. Okay, but let's go down here and actually put some numbers in there and see what's happening with this. And this talks about this. What happens if you have x, let's say you have x squared times x to the third power. Now, what does that equal? Usually people go wrong with this and they think, well, it's multiplication, so that 2 times 3 is 6 and the answer should be x to the 6th. Let me tell you, sorry, my writing is not bad, that is incorrect. Bad. If you break this down and think about what's really happening here, it actually makes a little more sense. What is x squared? X squared is x times x. What is x to the third power? X to the third power is x times x times x. So how many x's, and I'm multiplying those two things together, how many x's am I actually multiplying together here? You have 2 here, and you have the 3 here. So you end up with x to the 5th power. X to the 5th power. So that law of exponents, as you can see up here, okay, when you have exponents of the x, when you multiply those two bases together, you actually add the exponents. Okay, when you multiply like bases together, you add exponents, and that's what we're going to write up here. I might change colors just to mix it up a little bit. Let's see what happens here. So right here, just to give myself a little note, I might just put when you multiply like bases, you, and make this big number letters here, you add exponents. Okay, another example of that might be, and it could be numbers. If you have 3 to the 5th power and you multiply that by 3 to the 3rd power, that's the same thing as 3 to the 8th power. And I wouldn't do that because that's going to be a mighty big number. If you had y to the 9th power times y to the 10th power, you're going to get y to the 19th power. Okay, you don't multiply, it's not y to the 90th, it's y to the 19th power. All right, then moving on here to what about this, which is actually division. It shows it as a fraction there. Let's change to something really special. Let's go with a little hot pink there. And what that is, let's go down here to the bottom again, and let's see if we can't figure some heads nor tails out on this one. If you have, let's put numbers in there instead of letters. Let's say I have x to the 5th power, and I am dividing that by x to the 3rd power. And again, maybe you think you should divide those exponents, but that's not really the case. If we look at what x to the 5th power is, x to the 5th power is x times x times x times x times x, and that's all over x to the 3rd power, which is 3x's. And here's what happens. If you remember going back to I don't know, prime numbers when we made fractions and things like that, and whatever. If you have the same thing on top of a fraction as on bottom, they kind of cross off one for one. So these two x's could cross off, these two x's could cross off, and these two x's would cross off, and you're left with this, which is x to the second power. Maybe you picked up on this before, because division is really opposite of multiplication. If when you multiply, you add those bases together, when you divide, you subtract, which is what it shows right there. So let's write that in here. When you divide, bases together, you actually like bases. When you divide like bases together, you subtract exponents. You subtract exponents. So, and that's why they have x over a, x to the a power over x to the b is x to the a minus b. X can't be 0 because basically you could never have a 0 on the bottom of a fraction, and in this case here, but you don't have to worry about that. Now, children, here comes probably what could be the most exciting one of the day. Let's look at this third thing, which basically is right here, exponents to exponents. Okay, and again, I'm going to come over here so I have the room here. Let's say I have x to the third power, and that whole thing, that whole quantity, is getting, let's say, just squared, or no, let's do cubed. So it's x to the third power to the third power. Now this one, I don't know what you're thinking. If you do, cube 3 and get 27, that would not work for you. But again, break it down. Let's think about what's happening here. This exponent tells you you have 3 of these, 3 of whatever's in the parenthesis multiplied together. So I have x to the third times x to the third times x to the third. I have 3 x thirds getting to multiply together. Then if I break those down, what is x to the third? Well, that's x times x times x. What's x to the next third is another 3 x's. And that third one is another 3 x's. So if you look at how many x's I have here, 3, 6, 9. X to the third power is x to the 9th power. X to the 9th power. So the rule up here is, maybe you can see it, is, believe it or not, when you have exponents to exponents, you actually multiply the exponents together. And that's what we'll write up here. When you have exponents to exponents, you multiply. I'm going to work on my handwriting, by the way. Someday, you multiply x to the third, and that's why they have here x to the a to the b power is x to the a to the b power. We'll do a couple examples over here. What if we have, let's do, I don't know, x to the second power to the 5th power. Let's do that as one example. Let's do x to the second power times x to the 5th power. And then let's do x to the 5th power divided by x to the second power. What happens for these things here? Change colors one last time here. A little Christmas look going on here. Okay, first of all, for this one, x squared to the 5th power. Okay, what does that mean? First of all, it's exponent to exponent, so you know you're going to multiply exponents. So my answer should be x to the 10th power. And again, that's because I have 5 x squareds being multiplied together. X squared times x squared times x squared times x squared times x squared. 2, 4, 6, 8, 10 of them. X to the 10th power. This one, this is just x squared times x to the 5th. So that's a grand total of x to the 7th. You're just adding them together like we talked about here. And when you divide exponents, it's simply subtracting x to the 3rd power. That, ladies and gentlemen, is all you need to know about the laws of exponents for multiplication and division. Hopefully that helps you out a little bit with that. We will talk to you later. See you in class sometime.